Hey guys, today we're talking about sequences, and specifically we're talking about writing explicit formulas for those sequences. Now, a sequence is simply a function whose domain is the set of all positive integers. Now, an explicit formula is a formula that describes any term in the sequence based off its position in the sequence. Now, that position in the sequence is known as its term number. So let's take a look at this sequence here. We have 4, 8, 12, 16, 20, and 24, and it keeps going on and on. Obviously, you can guess that it's just multiples of 4. Now, writing an explicit formula for that means that we're going to write a formula in terms of the position numbers for those sequence values. So, for example, 12 right now is the value of the third position of this sequence. So how can I go about writing an explicit formula that generates this sequence of numbers? So let's just take a stab at it. I'm going to say S sub n, this is a subscripted n, is going to be 4 times n. Now n is going to represent the position or the index number of each one of these terms of that sequence. So 4 times 1 would give me the sequence of position number 1, which 4 times 1 would be 4. Same thing for the second position. 4 times 2 would be 8, so on and so forth. So you can see that this is an explicit formula that would allow me to generate this sequence of numbers. In example 2, we are asked to consider the formula t sub n is equal to 3 to the n minus 4. So you see here, this is an explicit formula that's going to produce a sequence of numbers. N, remember, is just our position number, or also known as our index number. Assuming that n is greater than or equal to 1, what are the first 4 numbers? So let's find t sub 1 simply by substituting the value of 1 in for n. 3 to the first power is 3 minus 4 is negative 1. T sub 2 is 3 squared minus 4. That's 9 minus 4, which is 5. 3 cubed minus 4 now is 27 minus 4, which is 23. And the fourth position here is 3 to the fourth minus 4. That's 81 minus 4, which is 77. Okay, so here's the first 4 numbers of this sequence: negative 1, 5, 23, and 77. It says to evaluate t of 10, sub 10 and explain what it means. Well, t sub 10, first of all, means that it's the 10th number or the 10th term in this sequence. In order to evaluate it, I'm going to say 3 to the 10th power minus 4. Its result is going to be really, really large. In fact, I have it written down here, and it is 59,045. All right, in example 3, we see that Alfonso has invested $750 for 1 year at an 8% annual interest rate. We are asked that if the interest rate is compounded semi-annually, how much will he have at the end of 1 year? Now, we have a formula for compounding semi-annually, and that's going to be the amount will be equal to the principal, which in this case is $750, times 1 plus the interest rate, which is 0.08, divided by 2, all raised to the 2 times the number of years it's invested. Since this is 1 year, we're going to say it's 2 to the first power. Now, in order to find that amount, we'll just throw that into our calculator, and we'll end up with $811.20. It says, how much money will Alfonso have at the end of the second and third years? Now, assuming that there's no withdrawals. Now, this can be easier to actually calculate just using our calculator. So I'm going to go show you how to do that on your graphing calculator. So as you pull up your graphing calculator here, we'll clear what's there, and we're going to go into our y equals. We're going to enter in our equation, 750 times the quantity of 1 plus, and then we're going to take our 0.08 and divide it by 2, close up those sets of parentheses, and we're going to raise that to the 2, we're going to include another set of parentheses there, 2 times x. and we'll close up that set of parentheses. Now, we could take a look at the graph there, but instead of going to the graph, we're actually going to take a look at the table. So let's see the table of values that were generated by this function. You can see I have $750 in the first year. At the initial, and then the first year I have $811.20, which is exactly what we came up with in our calculation. And the second year we have $877, and the third year we have $948.99. So let's go ahead and write that in now. It says how much will we have at the end of the second year. So our amount at year 2 will be equal to $877.39. And the amount at year 3 will be equal to $948.99. Again, this is a sequence of numbers. Final question says, and how much money will we have after 10 years assuming no withdrawals? This is another benefit of doing this on your graphing calculator and then going to the table, is that we can quickly and easily see how much he'll have at 10 years. If I scroll down, I'll see that value when x is 10. I go over and I can see that a of 10, or the amount he'll have in 10 years, is $1,643.30. All right, let's take a look at our last few examples here. In our check for understanding, we're asked, let E be the sequence of even numbers 2, 4, 6, 8. Who do we appreciate? Just kidding. We want to find the value of E sub 6. Well, remember that subscripted number represents the position number. So 2 is in the first position, 4 is second, 6 is 3, 8 is 4, 10 is 5, and the sixth position is the number 12. So we'll say the value of E sub 6 is equal to 12. Now it says which term is equal to 6. So which term is our third term? So we're going to say that that's E sub 3. The third term in that sequence is equal to 6. Next, we have two parts here. Number 2 it says find the first 4 terms of the sequence and then find the 98th term. So we're given the explicit formula for generating that sequence, and we say I sub n is equal to 12 divided by n. So our first term here, I sub 1, is 12 divided by 1, which results in 12. I sub 2 is the second term, which would be 12 divided by 2, results in 6. I sub 3 is 12 divided by 3, and that results in 4. The fourth term, I sub 4, is 12 divided by 4, and that results in 3. And then finally, the 98th term is I sub 98, which is equal to 12 divided by 98. And we'll just keep it as that fraction right there.